Thank you for downloading this podcast from The Reedy Clubby Show on Talk Radio 702 and 567 Cape Talk. For more, please go to 702.co.za or capetalk.co.za.
Choose to make a positive impact. Lead SA.
Talk Radio 702 and 567 Cape Talk. The Naked Scientist.
Chris, good morning.
Hello, Reedy.
Lovely to
Good to talk to you again.
Yes. It's been a while. It's lovely to be back. So we've been talking about this Mars mission, one-way ticket to Mars. And we had a laugh the other day about the kind of our politicians whom we'd like to send to Mars for them never, ever to return. But on a serious note, this Mars mission, what does it spell for humanity, Chris?
Well, it's the next big step, isn't it? Because on the one hand, we've conquered the Earth, sort of, and we've also, not for 40 years though, put somebody on the moon, and we've never put somebody on another planet. So what people would really like to do now is to break that hurdle and get onto Mars. And part of the reason for this is that there's a big population here on Earth. There are only so many resources here on Earth. We're going to have to look outside the Earth for some of the solutions to some of Earth's future problems. And inevitably, in solving the problem of how we do these sorts of very, very difficult to overcome missions, then we will inevitably discover new things that can improve life here on Earth for everybody.
But how will life be sustained on Mars, Chris? I've got so many questions about this.
Well, for a start, the atmosphere on Mars is very thin, and it's also chiefly carbon dioxide, which is a poison, because that's why we breathe it out. If it builds up in the bloodstream, it's acidic and it messes up with your body chemistry and you asphyxiate. So the only way we could survive on Mars is if we could make ourselves some kind of shelter or some kind of living environment, and that would be the something we had to send on ahead, or something that would come down with the space travellers who are going to live in it. More likely they'd send the accommodation ahead in some kind of robot which would assemble itself when it landed. And then we know that when our space travellers arrived after their 9-month to 10-month journey in space, long time, isn't it, that they would actually have somewhere safe to live. Now, the good thing about Mars is that the atmosphere being relatively thin, there's a reasonable supply of sunlight. So with good high-efficiency solar cells, you can generate electricity. So they could have some electricity, and that would provide them with the ability to make some warmth. It would also have the ability to enable them to extract raw materials, because the surface of Mars has got water locked up in it, so you could melt water out of the surface and purify it, and that would give the astronauts something to drink. You could also therefore potentially have crops, because you could have light and you could have warmth and you could have water, so you could grow things on Mars, but inside your environment, obviously, because Earth plants wouldn't tolerate the Martian environment outside. It's also extremely cold most of the time, and the radiation's very high, so you'd have to worry about that. And then you'd have to think, well, okay, we've done that, what are we going to do next? And then you're kind of thinking, well, I can't go back because it's a one-way mission, so you're going to have to come up with some very good board games or something, I think, to keep you amused.
And then, Chris, what sort of training goes into this? I read somewhere that each astronaut will be put through the required 8 years of training, that it took about 8 years for them to be ready. What exactly does that entail?
Well, I think one of the things that they need to be able to do is to get on with other people. So a lot of the training that goes into being an astronaut is enormous mental rigour and discipline. These people are also incredibly bright. Most of the people that I've ever spoken to from NASA and other space agencies who are either current or past or future astronauts are incredibly bright people. Most of them are scientists. A lot of them have got PhDs and do research into various aspects of physics, engineering and space science as well. So they would have to be bright people for a start. They'd have to be extremely well trained to get on and to handle the pressure that you're under, because you're under enormous psychological pressure on these missions, because they are dangerous, they are demanding, and they're very, very tiring. And then you've got to cope with the fact that your body is going to be suspended in a weightless environment for almost a year, between the time that you leave Earth and then you arrive on Mars. And that's going to take some dealing with, because we have not evolved for millions of years to have our body in a weightless state, and there will be enormous health consequences. It also screws up your body clock because there is no normal night and day half the time on these missions, especially when you're orbiting around the Earth, for example. You might have daybreak and then sunset 20 times a day. This may cause enormous havoc with people's psychology in the long term. So that needs to be considered. And then there's the whole, what do you do when something goes wrong? So that needs to be considered as well. So there's a lot that goes into making sure these missions, which are very expensive. I mean, just to put a rover on Mars, they're spending something like 20 million rand a day just to drive that Curiosity rover around on Mars. And I know that because I interviewed John Grotzinger, who's the PI, the lead investigator on that mission that's going on at the moment. And he said it's costing us $1 million a day in dollars to drive around on Mars. So we've got to get this right. It's too costly to mess up.
All right, very fascinating. I'm definitely watching this one. 0214460567 or 011-883-0702. The Naked Scientist is here, and we are stripping science down to its bare essentials, satisfying your curiosity about the world in which we live. Call us.
Talk Radio 702 and 567 Cape Talk. The Naked Scientist.
10:15, we go straight to the lines. Let's go to Denise in Tableview. Hi.
Hi, Rudy. Nice to have you back again.
Thank you.
I'd like to ask Chris, could you tell me, is genetic modification the same as cloning?
Hello, Denise. Well, the answer is it can be, but not generally. Cloning means copying something. So if I clone a piece of artwork, then I make something which is, to all intents and purposes, indistinguishable from the original. Now, nature does this because whenever we have a baby who is a twin with another baby and it's an identical twin, what's happened is that an egg, which has got a set of genetic material in it, has split in two early in development, producing two identical embryos because they've got exactly the same genetic composition, so you produce two babies that are clones of each other. It's not just humans that do this, because armadillos do this as well. There's a 9-banded armadillo, I think, and this automatically produces quads, has 4 babies, and I think that they're clones as well. I'm not 100% sure, but I think they're clones. But it definitely splits. It's definitely has four babies. Now, when we genetically modify something, though, that's where you're going in and saying, I'm going to make a conscious decision to change the genetic material in this thing in some way. And this can include taking genetic material away or adding genetic material. Why would you want to do that? Well, scientists understand that certain genes cause or can prevent certain diseases. And so there are times when you want to go in and add a gene in order to prevent a disease occurring, or take a gene away in order to make a disease occur, in order to study that disease, for instance, in an animal. And then there's a whole genetic modification of plants. Why would we want to do that? Well, there are some plants which have... Reedy, I'm getting the most horrendous echo. I'm sorry. It's really off-putting. Yeah.
Okay.
Thomas, and there are some...
Yeah?
And there are some plants which, when you want to add a gene to them, this means that you can make it defend against, say, an insect attack. Oh, it's a really bad echo, this. I'm really struggling to think if I can hear myself. And if you add a gene to the plant, then you can mean that you can give it the ability to, say, make another chemical which will make an insecticide. Or people are doing this with spiders, for example. They're taking the venom from a spider and putting the venom from the spider into a plant. So when an insect comes along and eats the plant, they get the spider venom and it kills them, but it's harmless to humans. So genetic modification means changing the genetic makeup of something. Cloning means copying it.
Okay, Chris, we're working on that one. I'm sure you'll indicate to me as soon as that is sorted out. Are you still hearing? You hearing it only when you're speaking?
Yeah, it's just me coming back to myself, but only when your microphone's open. So when you close your microphone, it goes away.
Then I'm not going to be part of this conversation. Okay, let me go. Let me go to Stephen in Edenvale, and then we'll switch off my microphone and hope that's going to sound better. Just let me know how it goes. Stephen, hi.
Okie dokie.
Good morning, Chris. Good morning, Reedy. I'd like to know, if there's lightning about and you're in a swimming pool, are you at risk?
Hello, Stephen. The answer is, and just so you know, there's no echo.
Okay.
The swimming pool answer, yes, you are at risk. And the reason for this is that if lightning hits the surface of a swimming pool, that's full of usually fresh water, and your body is full of salty water. Fresh water, paradoxically, or it may seem paradoxical, is not a very good conductor of electricity because there's no or very few what we call ions or charged particles. Fresh water is not very ionized. Whereas salty water, like the bag of water that your body is full of charged particles, so-called ions. Usually a lot of salt, sodium, Na, ions and chloride ions and bicarbonates, and these ions are very good at conducting electricity. So if a lightning bolt hits the swimming pool for some reason, then the electricity wants to dissipate or spread out from an area where there's a lot of it, where it hits the water, to an area where there's the maximum spread of the electrical energy. And if the water is difficult to go through because there are very few charge carriers, these ions, and you're in the way, then the electricity can see this beautiful superhighway for electricity in the form of all these charged particles in your body. So it will go out of the water, through your body, down your body, and then back out into the water again, giving you a pretty hefty shock in the process. If, on the other hand, you're a long way from where the lightning strikes, then the risk to you is reduced. And if you're swimming around in the sea, the risk is really very small indeed, because the sea has so many ions and charged particles in it that the electricity has enormous numbers of routes to flow all over the place, and it's not really very interested in hitting your body. But the same thing can happen if you're standing on the ground. If you're standing with your legs apart and the lightning strikes you down, say, on your left side, there's going to be a flow of electricity across the ground surface from left towards the right as the energy dissipates, and it can very easily go up your left leg, through your body, down your right leg and back into the ground, and cause some quite nasty burns in the process. And farmers report that occasionally they find animals that have died, and it looks like that's what's happened.
Thank you very much. Then, Stephen, let's go to Beres in Bloubergstrand. Good morning.
Good morning, Sister Judy. First, I've always been curious about this question, and I'll pose an example. If a person grew up in a sewage farm, and we know how they can smell, he only knew that smell all his life. And suddenly I introduced a rose to him, with a pleasant
Sorry,
smell.
Beres, is your radio on? We can't...
No, it's off.
Is it off? Okay, there's also an echo from your side as well. Okay, very quickly go through. The line is so bad, yeah?
Right. Okay, so if a person grew up and only known a bad smell, and I introduced a rose to them, would they know that's a pleasant smell? Or is it only by association that we know what is a good smell and what is a bad smell?
Did you get that, Chris?
Yeah, I think that there's some evidence that... now we've got an indicator. I think there's some evidence... I think there's a car indicator. I think there's some evidence that people have innate ability to distinguish what they regard as a good and bad smell. And this means that even though you may develop a tolerance to a smell, because anything that's present for a long period of time, and by long I mean more than an extended period of seconds or minutes, you have a process of what's called adaptation. And this is where your smell system turns down its sensitivity to the thing that's being presented all the time. And this means that you stop noticing it so much. And you notice this quite a lot when you, say, go to someone else's house. You walk into someone else's house and you think, there's a funny smell in here, or this smells different. But then after a few minutes, you don't notice it anymore. And that's because your sensory system has adapted. And we have this because we want to be interested in how things are changing, not things that are staying the same all the time. Because in order for our brain to pay attention to things, it needs to filter off things that are less important, because otherwise you would suffer sensory overload and there's no way you could ever spot what the new thing is. So if you were wandering around in a wood and a fire started, you need to know that suddenly there's a new smell, and that's smoke, but the normal smells of the woodland have been there all along. So you have this process of adaptation. I suspect that your notional person brought up in a sewage farm would get very used to the smell of sewage being around all the time. They would therefore notice it less while it was always there. If you took them away from that environment and then returned them to that environment later, they would nonetheless still suffer a degree of nasal offence. They would say, gosh, it smells here. And similarly, the nice smells of a rose, if you presented a rose to them, they would be sensitive to that smell, because the general smells of a rose would not be present all the time in the smells of the sewage farm. So they would notice the smell of the rose and they would say, gosh, that smells rather pleasant, because I think that, what we regard as a nice smell, it tends to be shared amongst the majority of the population. We tend to agree what smells nice and what smells nasty.
Let's go to Jenny. Jenny in Douglasdale. Good morning.
Hi, good morning, Reedy. Good morning, Chris. I just had a question about where does the colour of liquids that we ingest go to, from red wine to cream soda? Where does the colour go, considering that our urine comes out a light to a medium yellow?
Not if you've had beetroot.
I think you've got that, haven't you, Reedy? Do you get beeturia?
Chris.
Have you had that? No, I seem to remember a conversation where you said if you eat a lot of beetroot, then sometimes you do. Yeah.
Yeah.
Well, Jenny, the answer is that a lot of these plant and vegetable dyes, they are natural chemicals that plants make, and they are relatively easy to break down. And when you eat these things, they go into the body and the digestive system, whether that's the acid in the stomach, the proteases, the enzyme that break down protein in the stomach, and then the digestive environment further down the intestine, including the bacteria in the gut. Most of the time, that dismantles these chemical dyes and breaks the colours down, so that effectively there is no colour left. But there are some molecules in nature, and Reedy's highlighted one of them, the chemical which is in beetroot. It's called anthocyanin, which gives beetroot that beautiful deep blood red colour. This one, most people do break it down, but some people lack a gene which enables them to dismantle it, and it goes from the intestine into your bloodstream, circulates in the blood, and because anthocyanin is water-soluble, it goes into your kidney, and your kidney says, well, I don't really want this, and it chucks it into the urine. And this means that you can, fairly soon after eating beetroot, if you've eaten a lot of beetroot, you will accumulate a lot of this anthocyanin in your urine, and the urine will go red. And some people then go to the doctor because they're panicking, thinking they're passing blood, and it's actually the dye from the vegetable. So the answer is that the majority of these dyes break down, that some are resistant to being broken down, particularly in some people, and they then leave the body by whatever route. Sometimes they come out in the faeces, sometimes they come out in the urine. Other chemicals, which may not have a colour but nonetheless have a smell, like garlic, leave the body via other routes, on your breath, for example.
We know all about that. Let's go to, is it Kevin in Centurion? Good morning.
Hi, good morning to both of you. My question is, why do we tend to stick our tongues out when we concentrate very hard or try and do something which is difficult? I'm going to switch my phone off.
And stick your tongue out while you're doing it. Yeah. Hello, Kevin. I don't actually know that we know precisely why people do this. I can only think that it's a habit that we get into, and that it in some way helps some people to concentrate. There is an enormous amount of the brain devoted to controlling what your tongue does and what your tongue is feeling. It might be that by locking your tongue in one place like that, you stop your tongue exploring the inside of your mouth, which stops the tongue distracting you by picking up on sensations or other things from inside your mouth. And in this way, it means that you can divert more of your attention onto what you're trying to do at that highly taxing time. That is the best I can do. And if anyone listening to this has a better answer, then please do suggest it.
Yes, please. Mark in Broadacres. Hi.
Hi, how are you doing, Doc? There was an interesting question on Jenny's show, okay, with regard to comets. There's apparently a comet, a satellite that's going to land up on a comet which is going to the sun. Now, there was an interesting question yesterday. One gent phoned in and said he wanted to know if there's ice that is with the comets, where does the ice come from in space?
Yes, hello, Mark. You're absolutely right. Comets are what we call dirty ice balls or dirty snowballs. They are huge aggregations of ice and other molecules, including some rocky things and various minerals, that are left over, in the majority of cases, from the birth of our solar system. Some people regard them as effectively cosmic time capsules because they lock away in this pristine, very cold environment the remnants of what had formed us all about 4.5 billion years ago. And so as they melt away, when they come closer to the sun, which they do in some cases more often, in other cases less often, then they begin to spew out this material which is billions of years old. And by studying it, either directly by landing on it, which is what the Rosetta mission, which powered up earlier this week, is aiming to do later this year, or the other cunning way that astronomers can do this is to wait until the comet goes in front of the sun or between us and the sun, and then the light coming from the sun shines through the gases coming off the comet, and you can look at how the comet's gas affects the light from the sun, and because certain elements absorb certain colours of light, you can use what's missing from the spectrum of the sun to work out what must be in the comet. And that's another way that we can probe distant objects in the solar system and beyond. So the answer to this, where does this stuff come from? Well, it's left over from the formation of the solar system, and that when the material that formed another star and another body elsewhere in space, when that body blew to pieces, it deluged space with various bits of minerals and material, and they hover around in space, and various chemical reactions happen, and water's a very stable molecule made of two very common molecules that are in the... Not surprisingly, there's a lot of water in space.
Jimmy in Centurion, good morning.
Good morning. I just asked the professor, what happens to fuel that gets burned up by cars, aeroplanes, and things like that? Because after all, water that gets evaporated, it goes back to the earth. So what happens to fuel?
Right, okay, so when you have a hydrocarbon fuel in your car or aeroplane or whatever you're using, that consists of chains of carbon atoms surrounded by hydrogen atoms. When we react that in an engine, it's burned in the presence of oxygen. And so if you have a chain of carbon atoms and you add some oxygen to them, you get carbon dioxide produced and you get H2O, water. And so the products of burning a hydrocarbon to completion, in other words, that you add enough oxygen to react completely with your fuel, means that you make some heat, which is why the engine gets hot and makes the gas expand, which is why the engine works. You also make water as a product, as you said, and carbon dioxide. Now, in reality, what happens is that the chemical burning isn't complete. There's often a slight excess of fuel over the oxygen supply, so you get what's called partially burned hydrocarbons, and this is where you have short chains of carbon atoms which haven't completely broken up into carbon dioxide, and they are known as soot. And so when you see an engine belching out black smoke, that's where it's putting more fuel into the engine than it's got oxygen around to burn it, and so it comes out as smuts and partially burned hydrocarbons.
Chris, lovely to connect with you again. Let's do it again next week, Friday.
Oh, I'm looking forward to it. Thanks, Reedy. Thanks,
Cheerio.
everyone. Have a nice weekend. Bye-bye.
Bye. And don't forget, all our conversations with Chris Smith are available as a podcast. I'm so sorry about that bad line. Thomas will fix it next week. So you've got a week's break and then we're going to fix it for next week.